Pluto is a faraway, difficult to find, and less conspicuous planet that was once considered part of our solar system. Despite recent groundbreaking assertions from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku, Pluto has been brought back into public discussion. They've suggested that this icy planet might be heading toward a potential collision course with Neptune. However, how could such a scenario exist, and what would the consequences be of such a significant event? Are we witnessing a strange and unexpected phenomenon, or is there something more to this impending cosmic disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, which was once classified as a planet but later reclassified as a dwarf planet, continues to be a subject of fascination and study within the vast universe. Recent speculations from leading experts have suggested that Pluto's orbit is alarmingly close to Neptune's, prompting astrophysicists Neil deGrasse Tyson and Michio Kaku to warn people that a catastrophic encounter between these two celestial bodies could pose a significant risk to Earth. But how could such a collision even occur? Pluto's orbit around the Sun is unlike that of any other planet in our solar system.
Ow.
It takes a staggering 248 years to complete one full orbit. And since its discovery in 1930, Pluto hasn't even finished a single full revolution. However, the level of intrigue does not end there. Pluto's orbit is characterized by its distinctly elliptical shape, straying far from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its tilt. Its orbit is inclined at an angle of 17 to the plane of the solar system, creating a far more erratic trajectory compared to the more orderly orbits of the other planets, adding complexity to its orbital dynamics. One of the most fascinating aspects of Pluto's orbit is the way it intersects with Neptune's. For roughly 20 years in each orbit, Pluto actually travels closer to the Sun than Neptune does, defying the normative expectation of their relative positions in the solar system. Naturally, this raises the question, why hasn't Pluto collided with Neptune? The answer lies in the forces of gravity exerted by other planets. After Pluto's discovery, astronomers quickly set out to comprehend its peculiar orbital behavior. In contrast to the other planets whose orbits are relatively close to the solar plane, Pluto's orbit stands out because of its steep inclination and highly irregular shape. As the puzzle became clearer, it was evident that Pluto's orbit intersects Neptune's. Despite this, Pluto's orbit remains stable, demonstrating the intricate dynamics of celestial mechanics, or the so-called three-body problem in space. Understanding how three objects like Pluto, Neptune, and the Sun interact gravitationally is essential for this scenario. It's like trying to predict where these objects will be based on where they started, how they influence one another. The stability of the orbits of all planets is guaranteed by the notion of libration, which in the case of Pluto and Neptune is not simultaneous. This means that whenever Pluto crosses Neptune's orbit, the two bodies are always positioned at least 90 apart. This spatial separation prevents a collision between them. Another contributing factor is orbital precession, which refers to the slow vertical movement of a planet's orbit. For Pluto, this means that when it comes closest to Neptune, or any giant planet, it is positioned well above their orbital plane, providing another layer of protection from potential collisions. An additional factor at play is the VSK wobbling, a concept named after three researchers, Zeldovich, Sitnikov, and Kozai, who studied how one celestial body interacts with another's gravitational pull. This wobbling effect explains why Pluto's orbit, though seemingly chaotic, remains stable for a long time. The gravitational tugging between Pluto, Neptune, and the Sun influences Pluto's orbit to ensure it stays relatively smooth despite its irregular shape. VSK wobbling shows that even in the most erratic environments, there are underlying patterns and forces that maintain stability. This three-body problem is crucial to understanding the nature and relationship of Pluto's orbit with Neptune and other distant objects in our solar system. Numerical simulations carried out in the late 1980s revealed that, despite stabilizing forces at play, Pluto's orbit is actually quite erratic. A few minor initial circumstances may result in significant differences in its path over centuries. Nevertheless, These simulations also showed that Pluto's orbit maintains stability over very long timescales, such as millions or even billions of years. To fully grasp the dynamics between Pluto and Neptune, it's important to consider the gravitational influence of massive planets in space, like Neptune, Jupiter, and Saturn. Neptune's influence is significant as it governs Pluto's orbit in a special resonance. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This gravitational resonance helps to keep Pluto's orbit stable. But Neptune is not the only player in this complex equation. Additionally, Jupiter's enormous gravity plays a key role in stabilizing Pluto's path, while Saturn further contributes to this dynamic. These forces, working together, ensure that Pluto remains on a steady course for potentially millions of years, keeping it out of harm's way from Neptune's influence. Without these stabilizing forces, the solar system would be much more chaotic, with planets potentially colliding or being ejected from their orbits, causing catastrophic consequences across the solar system. The possibility of Pluto colliding with Neptune in the future emphasizes the complexities of celestial mechanics and the importance of studying the stability of orbits. By understanding these intricate dynamics, we gain a better comprehension of how the solar system works, the role of gravitational forces, and the behavior of distant objects. Despite the fact that Pluto's orbit may appear chaotic at first glance, it is a testimony to the delicate equilibrium of forces that keep it in place. Exploring space frequently produces unexpected discoveries, and Pluto's irregular orbit serves as a prime example of the mysteries of the universe. The idea of chaos in orbit shows how a celestial body's orbit can be highly dependent on its starting location. In Pluto's case, even small changes in its position or speed could drastically alter its long-term orbit. Automated simulations have proven invaluable in helping scientists study these behaviors by modeling how Pluto and other objects, like Neptune, influence each other through their gravitational pull. Simulations show how even the tiniest changes in the environment can have a significant influence on Pluto's course. Though Pluto's orbit is stabilized by mechanisms like precession and libration, simulations have shown that Pluto's orbit is far from consistent. Small deviations in its initial circumstances can result in vastly different outcomes, making predictions about its future movement extremely challenging. Despite this apparent chaos, Pluto's orbit remains relatively stable over geological durations, on the order of billions of years, providing evidence that, despite the apparent chaos, there is an underlying order to Pluto's motion around the Sun, predicting celestial movements, especially for objects with irregular orbits like Pluto, is a massive challenge. The inherent unpredictability of these systems signifies that any long-term forecast is filled with uncertainty. Numerical models help us understand and predict these movements, but their accuracy depends heavily on precise initial conditions. Initial conditions, even a slight error, can result in vastly different outcomes. From the planet's chaotic nature, orbits tell Pluto's story, serving as a reminder of the dynamic and ever-changing nature of the universe. Despite the many advances in our understanding of space, Pluto's case demonstrates how much we still have to learn. Grasping the gravitational influences of the giant planets that orbit Pluto provides us with important insights into the broader mechanics of the solar system, showing how the position of each planet can significantly affect the course and stability of others. Why are prominent astrophysicists raising concerns about a possible collision between Pluto and Neptune, despite all these stabilizing forces at play? Neil deGrasse Tyson, leading astrophysicist, and one of the figures responsible for Pluto's reclassification from a planet to a dwarf planet, offers an insightful perspective on the ongoing mysteries of our solar system, including Pluto's future. Tyson has played an important role in reshaping the public's understanding of Pluto and its perception, as well as its place within the evolving landscape. Tyson examines Pluto's reclassification not as a loss, but as an essential adjustment based on our expanding knowledge of space and celestial bodies. Tyson's approach to celestial mechanics is one of constant discovery and evolution. He sees the complexities of orbits like Pluto's as indicative of how much more there is to learn about the universe. Although Tyson remains hopeful regarding the study of space, His views on Pluto's potential collision with Neptune suggest that there are still many unanswered questions. Will Pluto collide with Neptune? Or is this merely a momentary confusion in the ever-evolving cosmic system? Only time and additional investigation will provide the answers. For now, we are left with an even greater curiosity about how much remains unknown in our own solar system. Potential for a Pluto-Neptune collision invites further investigation into the mysteries of the universe and challenges our understanding of planetary dynamics. The prospect of two celestial bodies with vastly different properties colliding raises interesting questions regarding the gravitational interactions that shape the development of the solar system. The collision of Neptune and Pluto would not only have major implications for our understanding of planetary behavior, but would also provide valuable insights into the evolution of the solar system itself. To understand the dynamics of a potential impact between Pluto and Neptune, it's essential to consider the characteristics of these two planets. Despite its designation as a dwarf planet, Pluto contains a variety of elements and compounds in a frozen state, thanks to the extreme cold of the outer solar system. This substance, nitrogen ice, covers its surface, and its atmosphere is primarily made up of nitrogen, methane, and carbon monoxide. In contrast, Neptune, a massive gas giant, consists mainly of hydrogen, helium, and other lighter elements that form a dense, deep atmosphere. A collision between these two vastly different bodies would undoubtedly have a significant impact on both planets, possibly triggering an event that could be seen from vast cosmic distances. However, it's important to note that the gravity of Neptune is not the only stabilizing force at play. Jupiter, the largest planet in the solar system, also possesses a substantial gravitational pull, contributing to Pluto's stable orbit and keeping it away from too close proximity to Saturn's domain. Neptune's gravitational influence further complicates the interactions in the outer solar system, making it unlikely that a devastating collision between Pluto and Neptune will occur. While Neptune's gravitational influence plays a dominant role in stabilizing Pluto's orbit, the complex relationships between other planets such as Jupiter and Saturn further ensure that Pluto's path remains steady. Other studies have also shown that the relationship between Pluto and Neptune is not as straightforward as a potential collision course. The gravitational resonance between the two planets, where Pluto completes 2 orbits for every 3 Neptune completes, creates a natural barrier that prevents collisions. This resonance, frequently described as a dance of gravity, ensures that Pluto and Neptune's orbits, while intersecting, never result in a collision. This mechanism is quite an extraordinary example of how celestial bodies can maintain a harmonious relationship despite the chaotic forces at work in space. Yet, the future of this delicate balance is not guaranteed. Small shifts in the positions or velocities of these planets could disrupt this resonance and lead to unpredictable consequences. These shifts could be triggered by external forces, like the gravitational influence of an unknown planet or a fleeting star, or by internal events, such as tidal forces causing gradual changes in the orbits of these bodies. Continued study and observation of Pluto, Neptune, and the surrounding bodies in the outer solar system are necessary for comprehending the long-term stability of their interactions. As technology advances, researchers will be able to improve models and gain a clearer understanding of the dynamics between these distant objects. New data may shed light on the delicate equilibrium that holds Pluto and Neptune from colliding, or it might reveal entirely new forces that could alter their relationship going forward. As we continue to study the dynamics of Pluto and Neptune, one key factor that has emerged is the possibility of an unidentified object that influences orbits. This hypothetical object, often referred to as Planet 9, is believed to exist in the far reaches of the solar system. According to some scientists, its gravitational pull could alter the orbits of objects like Pluto, possibly leading them to try new paths that could shake up their current positions. While Planet 9 is still a subject of debate, its potential impact adds another layer of complexity to the situation. In addition to the gravitational interactions between planets, important to consider the broader context of how the solar system as a whole is evolving. The Sun, being the dominant gravitational force in the system, is gradually losing mass through the process of solar wind. As the Sun loses mass, the orbits of all the planets, including Neptune and Pluto, could gradually expand over time. This process could shift their relative positions and affect the long-term stability of their orbital resonance. Furthermore, the outer solar system is not a fixed location. Objects like comets and other small bodies are always moving through, exerting their own gravitational forces. These passing objects could occasionally perturb distant planets' orbits, including Pluto's. Even though such occurrences may be rare and unpredictable, the combined effect of these varying forces may ensure that Pluto's orbit remains dynamic. It's constantly changing in response to the gravitational dance that occurs between the planets.